Since we learned about drawing graphs to represent inequalities in our last lesson, this time we're going to be writing inequalities from graphs, which requires a little bit of working backwards based on what we learned in our last lesson. A brief review from the last lesson. Remember, an open circle is only used for greater than and less than. Possible solutions cannot equal that number. So if you have an open circle on a number, a solution cannot be the number that that circle is on. A closed circle is only used for greater than or equal to and less than or equal to. And remember that line underneath is a half of an equal sign, which means that if this dot is on that number, a solution can include the number that that dot is on. Helpful hints to write down. When you're solving these kinds of problems where you have to work backwards from a line, a number line, always look at the type of dot first. That's going to tell you what type of sign to use. Then, the second thing you're going to look at after the type of dot is the direction of the shading. If the shading on the number line goes to the left, you're going to know that that's less than or equal to. And you should already know, if you did the first step correctly, which one of these you'll pick. Now, if the shading is going to the right, that means it's going to be either greater than or equal to. And your type of dot is going to tell you which that is. And then lastly, you're going to make sure you know the number location of your dot before writing your inequality. So make sure you know what number that dot is on before you finally write your inequality with the sign and the variable. Let's try some of practice problems together. Make sure you organize all of your work as neatly as possible so you can use it when you're doing your independent practice problems later. Let's start with our first number line. Now remember, the first step was to look at the type of dot we have. And we know that we have an open dot, so it's either going to be less than or greater than. It's not going to have the equal to bar underneath. And then we look at where the shading is. The shading is on the left-hand side, so that tells us it's going to be less than. And the reason we don't have the bar underneath is because it does not equal the -3. So since the dot's on the -3, that's our number in question, and we have x is less than -3. Again, we look at the dot first. It tells us it's going to be either greater than or less than, but not equal to, so it's open. Then we look at the direction. It's going to the left, which tells us it's going to be less than, and we look where it is. It's on the -3, so that tells us x is less than -3. And possible solutions for this, it can't be -3, but it can be -4, -5, and these numbers are possible solutions. Even though 4 and 5 are higher than 3, they have a greater distance from 0. So they're farther away from 0, so they are actually smaller. The farther left you go, the smaller the numbers get. So -4, -5, -6, -7, and so on. But -3 cannot be a solution because it has to be less than -3. For our next problem, let's look at this number line over here. We have a closed-in dot. So that means it's either going to be greater than or equal to or less than or equal to. Now we look at the direction. It's going to the right, so it's going to be greater than. So that's the sign we're going to use, greater than or equal to. Now in this one, the numbers are labeled a little bit differently. We have increments of 2. We're going up by 2's. So halfway in between 1 and 2, we know is 1. So the number in question is 1, and then we put our variable on the left-hand side. So this tells us that x is greater than or equal to 1. We saw our closed-in dot, so we knew that it was this, or greater than or equal to, or less than or equal to. Then we saw that the shading was on the right-hand side, so we knew it was greater than or equal to. And our dot is on the 1. So our solutions could be 1, since it's a closed-in dot. We could even do 1.5, or 2, or even 2 1/4. Anything that is 1 or greater can be a solution. For our next graph, I look at the circle first. It's an open circle instead of a closed circle, so that means I know it's either going to be greater than or less than. No line underneath because it's not a closed circle. Now I look at the direction of the shading. The shading is on the right-hand side, which means it's greater than. So we're going to use greater than since all of the shading is bigger than -2. So this is our sign. Our number is -2, and then we put our variable in. X is greater than -2. That means all numbers that are larger than -2, not including -2, are possible solutions. So we can have -1, 0, 1, 2, and 3, and so on. For our last problem, we go look at the dot first. It's closed, so we're either going to use greater than or equal to or less than or equal to. And I look at the shading next. The shading is on the left-hand side, so we're going to use less than. So I'll put my sign in, and I look to see where my number is, or my dot is. It's on the 40, so whatever we have, it's going to be less than or equal to 40. Put your variable in. So now we have x is less than or equal to 40. So that means possible solutions. Anything that is 40 or under. We can include 40 this time because x can equal 40. And -20 is a solution, 0, 20, -60, and remember, anything farther away, anything that's on that shaded number line is a solution, and so on. So now I want you to try your independent practice problems. Refer back to the video and your notes if you need to.